So we're starting our new unit of graphing quadratics. This is what you guys are going to be graphing. This is called a parabola, which I've shown you guys before a couple of times. So this is what you're expected to be able to do. So we're just going to kind of start off going over like what this graph can look like and how to manipulate the equation to get it to do different things. So this is the parent equation. That's just like the general equation for a parabola, y equals x squared. And it looks like this again. So it's centered right at the origin at 0, 0. And then so I'm just going to play with the equation a little bit just to show you what else it can look like. Let's see. So if I make it a negative x squared, it flips it upside down. So now it's a downwards parabola. Okay, so then if I do that, it just goes back to normal. So technically the number in front of the x squared is a 1. So if, let's say I make it 10, if you notice the parabola got a lot skinnier, it got stretched out. And if I do an even bigger number, let's say I do 20, it gets even skinnier. So the bigger that number in front of the x squared, the more stretched out it's going to be. So let's go back to 1. There's the standard one. And then let's do 0.5, less than 1. It gets a little wider. So let's try 0.25, a little wider. And then even if I do 0.05. So it gets super wide. That's actually called compressed. It's kind of getting like more flatter. So the closer you get to 0, the more flatter it's going to be. And then that's just what it looks like normally. So if you notice, it was always centered at the origin, 0, 0. So we could actually move it. Let's see. So if I do like plus 4, now it's center, it moved up 4 units from up here. So that's if I add 4. Let's do if I minus 4. Now it just went down 4. And then you could also move it left to right. This one will be a little different. Kind of have to change the equation. So if I do x minus 3, it moves to the right 3 units. And then if I do plus 3, it actually moves left 3 units. So we'll go over this next week with this type of equation. Basically, whatever the opposite sign is, that's the direction left or right it's going to be moving. But yeah, so that's basically the graphs of what we're going to be doing. Again, these are called parabolas. So with parabolas comes with a lot of vocabulary. So I put a link on the agenda sheet so that you guys can have all the vocabulary. So I have mine right here. Okay, so this is what the vocab looks like. Hopefully you can print it out. If you do have a printer at home, I highly suggest printing it. It'll just be really useful to have next to you during this whole unit, especially since we're doing everything online. But if you can't print it, that's fine. There's the PDF version on the locker, and on the agenda link, you could open it from there as well. So I'm just going to go over everything, kind of explain what everything is, because you guys are going to be answering a lot of questions each time you do graph a parabola. So like what I just showed you, that graph is called a parabola. It's a curve. It's a U-shaped graph. The vertex, that's the center point of the parabola. So it's basically just that point right here. And so in this case, for this graph, the vertex would be at 0, 0. And for this parabola, the vertex would be here. And it says right there, mine's a little faded, but the vertex would be 2, 3. So it's just that middle point. Down. So like I kind of showed you, that didn't work. The parabola can have different shapes. So and I'll explain what A is in a different video, but when A is equal to 1, that's the standard shape of the parabola. So it's kind of just like a normal U shape. When A is between 0 and 1, so like I showed you on my computer when it was like 0.5x squared, it gets a little flatter. That's called a compressed parabola. And then a stretched parabola is when A is greater than 1. That's when I did like 10x squared and 20x squared. So the bigger that number is, the more skinnier or stretched it's going to get. Orientation, so that's just the direction of how the parabola is opened. So upwards, it's just regular U, and then downwards, it's just upside down. And then that's going to depend on whether A is positive. So if you want to put a note there, A is positive. And then this one, that's when A is negative. So when we're graphing, there's a lot of information that we're going over, just like the shape, where the vertex is, the orientation, and then sometimes there's going to be a minimum. This is only going to be when the parabola is facing upwards. So it's this shape, and then your minimum, it's like your lowest y value of the graph. So if you think about it, it's like your minimum point, it's the lowest it's going to go. Because your parabola is facing upwards, so there should be arrows on this technically. So it's going up and up forever and ever, and it won't go any lower than this point. That's why it has a minimum. And it's always the lowest y value. And so for this one, since your lowest y value, it's always your vertex, it's just y equals 2. So I put that note as well. Will always be the y value of the vertex. And then there's a maximum. So this is only when the parabola is facing downwards, because like this one should also have arrows. It's going down and down forever and ever. So this is the highest point it's ever going to reach. That's why it's called a maximum. And then same thing, it's always the y value of your vertex. But then since it's facing downwards, this is your highest y value. So in this case, your minimum would be, maximum, sorry, is y equals -1. So just know the difference. If it's facing upwards, you have a minimum, you have a lowest point. And if it's facing downwards, you have a maximum because you have a highest point. Axis of symmetry. So this is an imaginary, I can't say that word, the imaginary line that goes through the vertex. So symmetry means it's equal on both sides. Like if I folded the parabola on this line, it'd be symmetrical. So this line, this green dotted line, won't always be there. That's why I put imaginary line. So it goes through the vertex wherever it is. So this one, the vertex is 0, 0, so it just goes right there. And then your axis of symmetry, it's always the x value of your vertex. So since my vertex was 0, 0, our axis of symmetry would be at x equals 0 because it's a vertical line. That's why it's that equation. And then this one, this is your vertex. It's going to be the x value of your vertex. So my axis of symmetry would be x equals -1. And then the next thing, sorry, I'm like running out of breath. Domain. Hopefully you've heard that word before. Basically what domain is, it's how far the graph goes from the left to the right. Basically all possible x values. So it's kind of like if I'm looking at this graph, it wants to know all the x values from all the way to the left, all the way to the right. But the parabolas that we're going to be working with, they extend forever and ever. So again, like this would have arrows. So they're never ending. So since that's happening, this graph is extending to the left forever and ever. And then same with this way, all the way to the right. So there's two ways you can represent domain. This is a math symbol. It means all real numbers. So basically, this is how you could write it. It's like a capital R, but just with 2 lines. So if you just want to do an R and then add a line, that just means all real numbers. Or you might see it like this. This is just saying it's going to go from negative infinity all the way to positive infinity. So that's how your domain's always going to be. Range is kind of similar, but it's talking about how far the graph goes from the bottom to the top, basically all your y values. So domain is x values, range is y values. Range is going to depend on the orientation of your graph. If it's facing upwards like this one, all you're going to do is just put the y value of your vertex and then to infinity. Because basically when it's facing upwards, the lowest point that my graph is ever going to go is here. And then it's extending up forever and ever and ever. That's why it's to infinity. And then a downwards graph. So again, you start from top to bottom. So the lowest, like say this graph is ever going to go is negative infinity. And then the highest it's ever going to go is the y value of my vertex, which is 3. So let me just write those so you can kind of see. So it's always going to be, for upwards, it'll be a number. So it's the y value of your vertex. So let's say this one, that would be 0, and then to infinity. And you do have to use those brackets because this bracket means it's like exact. This is like an estimate. And then if I have a downwards parabola, let's do this one for example. So the range, the lowest it's going is negative infinity. And then the highest it goes is positive 3. And then I use the hard bracket because it's exact. So just got to know whether it's upwards or downwards. And then I think this is the last one, yeah. So the last thing we're going to go over is end behavior. This describes the direction of the graph that the graph is going. So again, it kind of depends whether it's going upwards or downwards. Let me use this one again. So if it's facing upwards, like this one, it's basically talking about like, okay, as the x values are approaching infinity, what are the y values doing? So if it's going upwards, x is going to infinity, and then since it's going upwards, that means y is also approaching infinity. Then the other way, as x approaches negative infinity, which means this way, y is also going up, so it approaches positive infinity. That's how you'll always write the end behavior for upwards graph. And how you read that is as x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches infinity. So then if you have a downwards graph like this one, it's the same thing. The only thing that's going to change really is your y, because now as x approaches infinity, now your graph's going downwards, so y is approaching negative infinity. And then as x approaches negative infinity, so as it's going this way, your graph's going down, so all your y values are going towards negative infinity. So your x's, one's always going to be positive and negative because it goes left and right. And then your y values will be the same depending if it's upwards or downwards because it's the same on both sides. So hopefully this wasn't too confusing. I try to make it as easy to understand as I could, but I know it's hard because it's all online. So if you do have a printer, it would be helpful if you could print that out just so you can have it. But if not, just use the Google Doc or the PDF version I made for you. So after you watch this video, go ahead and do the quizzes assignment just to practice with the vocab, see if you got it. Okay, hope you guys are well. See you soon. Bye.